Welcome to my new video series on solving puzzles using AICs with extensions. In this video, I will demonstrate solving the hardest puzzle I've ever solved using just logic. I will be using the two algorithms presented in dxSudoku video number 107. I've updated step 2 of the general puzzle solving algorithm to include the uniqueness test type 1. Uniqueness test 1s are so easy to spot, I figured this technique should be included. Here are the prerequisite videos for this video. Strap on your seatbelts, here we go! Consider the following Sudoku puzzle loaded into Sudoku. Sudoku is rating this puzzle as extreme with a difficulty score of 5,348. You can see the summary section is showing the puzzle solving techniques Sudoku's solver would use in solving this puzzle. As you can see, there's a nice symmetry to the constellation of givens in this puzzle. This is a much harder puzzle than the ones I demonstrated in dxSudoku video number 106 and video number 107. This puzzle cannot be solved without using X nodes or extensions as part of our AIC chaining sequence. Because solving this puzzle will require using X nodes, I will be going through each chaining sequence in more detail. I will begin by doing step 1 and step 2 to get as much done on the puzzle as possible before doing any chaining sequences. I'll be right back. I'm back. Here are the results from step 1 and step 2. We are now ready to start looking for AIC chaining sequences. Based on the algorithm, I decided to choose the 4 in cell 3, 9 as our starting candidate for our chaining sequence. There are 6 candidates colored in dark gray to be targeted by our chaining sequence. The first link in the chaining sequence is a strong link to the 4 in cell 3, 1. I've changed my chaining sequence notation to just include the next node and its state in the chaining sequence. What I mean by state is when I color a candidate purple, meaning we are pretending it is off, or dark green, meaning we are pretending the candidate is on. Each node added and its state depends on all the previous nodes and states as our chaining sequence is being built out. The next set of nodes have been added to the chaining sequence. We have 2 new strong links added to our chaining sequence. And we have 18 new weak links added to our chaining sequence. Take a closer look at cell 4, 1 and cell 8, 1. The candidates in these 2 cells form a naked pair X node we can use as part of our chaining sequence. The naked pair X node candidates are now highlighted in light red. Because of the naked pair X node, the candidates now outlined can be colored in purple. We add 2 new weak links to our chaining sequence because of the naked pair X node. The first naked pair X node opens up a second naked pair X node, which allows us to add 1 new weak link to our chaining sequence. The next set of nodes have been added to the chaining sequence. We have 6 new strong links added to our chaining sequence. And we have 16 new weak links added to our chaining sequence. Next, we find a set of X node lock candidates with the 7 in row 4, which adds 2 new weak links to our chaining sequence. And we find a set of X node lock candidates with the 3 in column 1, which adds 1 new weak link to our chaining sequence. A bunch of new strong and weak links were added to our chaining sequence. Take a closer look at cell 1, 8 and cell 7, 9. Both these cells have a target 4 candidate colored in dark gray. Since all the non-4 candidates in both cells are colored in purple, we must choose 4 as the pretend value of the cell by coloring it dark green. Because the 4 in cell 2, 8 is on, and the 4 in cell 7, 9 is on, then our target 4 candidate in cell 2, 9 becomes a non-possible candidate. We mark the 4 candidate in cell 2, 9 in red to indicate that it is a non-possible candidate. Next, take a closer look at the 2 candidate in cell 3, 1 and the 2 candidate in cell 3, 4. These 2 candidates form a group node strong link with the 2 candidate in cell 3, 9. The 2 in cell 3, 9 is colored in dark green to indicate that it is on as a result of our chaining sequence. Because the 2 in cell 3, 9 is on, then our target 6 and 8 candidates in cell 3, 9 are non-possible candidates based on our chaining sequence. We mark the 6 and 8 candidates in cell 3, 9 in red to indicate that they are non-possible candidates. Eliminating 3 out of the 5 target candidates is a very successful chaining sequence. The non-possible candidates are removed from the puzzle, and just like a Tibetan sand mandala being swept away, we clear off all the candidate colors from the puzzle. Next, we do step 1 and step 2 to clear off any additional candidates, but at this point in the puzzle, there are no additional candidates to clear off. So we choose a new starting candidate and prepare to do another AIC chaining sequence. I have chosen the 4 in cell 8,8 to be our starting candidate for our second chaining sequence. For this chaining sequence, we have 3 target candidates, and our chaining sequence is starting out with 2 strong links. I built out the chaining sequence to this point, and no X nodes were required for this sequence. Take a closer look at cell 8,3. The 6 and 8 are both off. This means our target 4 candidate is on. The 4 candidate in cell 8,3 is now highlighted in dark green. So this target candidate cannot be removed from the puzzle based on this chaining sequence. Next, consider the 8 candidate in cell 1,8. This candidate is colored in dark green, indicating that for this chaining sequence, it is on. This means the target candidate in cell 8,8 is a non-possible candidate. The 8 in cell 8,8 is now colored in red to indicate that it is a non-possible candidate. And I updated the 7 candidate in cell 8,8 to be dark green, since it's the only one left, so it must be on. The non-possible candidate is removed from the puzzle, and the candidate colors are reset. Removing just one candidate may not seem like a big result, but the 8,8 now being a bi-value cell will help us later in solving the puzzle. Next, we do step 1 and step 2 to clear off any additional candidates. But again, at this point in the puzzle, there are no additional candidates to clear off. So we choose a new starting candidate and prepare to do another AIC chaining sequence. The target candidates are highlighted in dark gray, and the first link in the chaining sequence has been added. Notice how the first link in the chaining sequence is to the 6th candidate within the same cell as the starting candidate. As long as our chaining sequence begins with a strong link, everything is good. I started building out the chaining sequence. Notice how the 1 in cell 7,3, now colored in dark green, causes the target 3 candidate in cell 7,3 to be marked as a non-possible candidate. It may be tricky at first using 4 colors in our chaining sequence. It takes a little practice to get good at doing this technique. Just remember, green is green, purple and red mean off, and dark gray is the same as not having any color at all. Notice we have a naked pair X node in row 6, now highlighted in light red. The naked pair X node causes the 3 in cell 6,1 to become a non-possible candidate, the 8 to be colored in purple, and the 5 to be colored in dark green. At this point, the chaining sequence stalls and we cannot go any further. The non-possible candidates are removed from the puzzle and the candidate colors are reset. Next, we do step 1 and step 2 to clear off any additional candidates. This time, with step 1 and step 2, we are able to remove some additional candidates. We are now ready to begin our 4th AIC chaining sequence. The starting candidate is the 8 in cell 8,1. We have 7 candidates to target with our chaining sequence, and the first strong link in the chaining sequence is the 7 in cell 8,1. I started building out the chaining sequence. Take a closer look at cell 4,1. The 4 candidate in cell 4,1 is now highlighted in dark green. This means the target 8 candidate in cell 4,1 is a non-possible candidate. We have a 4,8 naked pair X node now highlighted in light red in the house making up column 2. The naked pair X node allows us to add 2 additional weak links to our chaining sequence. Take a closer look at the 8 candidate in cell 6,1 and the 8 candidate in cell 6,3. The 8 candidates in these 2 cells form a set of X node lock candidates now outlined. The X node lock candidates allow us to add 2 new weak links to our chaining sequence. This one step may be the key to solving the whole puzzle, because as you can see, it opens up a number of strong links and our chaining sequence does not stall. I made good progress on the chaining sequence. Take a closer look at cell 6,3 and 7,3. Both cells have a non-target candidate colored in dark green. This means both target candidates are non-possible candidates, now highlighted in red. Since the 8 candidate in cell 8,7 is the only remaining 8 candidate in block 9, not colored, we color it dark green. One of the two remaining target candidates in the house making up column 1 has to be on and the other has to be a non-possible candidate. The answer is going to come from the 5 candidate in cell 6, 9. Our chaining sequence is now complete. We were able to mark 4 out of the 6 candidates as non-possible candidates. The non-possible candidates are removed from the puzzle and the candidate colors are reset. Next, we do step 1 and step 2 to clear off any additional candidates. We actually set a value. This is a really hard puzzle, but we are making progress. I'm thinking one more AIC chaining sequence will solve it. We begin our 5th AIC chaining sequence using the 8 in cell 2, 2 as the starting candidate. We have 8 candidates to target with our chaining sequence, and the 4 in cell 2, 2 is the first strong link. I made good progress on the chaining sequence. There's a naked triple X node in row 5, a naked pair X node in row 9, and a naked pair X node in column 7. I finished the chaining sequence, and 6 out of the 8 target candidates are now marked as non-possible candidates. The non-possible candidates are removed from the puzzle, and the candidate colors are reset. Next, we do step 1 and step 2 to clear off any additional candidates. After a crazy number of naked singles, the puzzle is now solved. Solving puzzles with AICs video number 1 is complete. Please support dxSudoku. Thank you for watching.